Welcome back, welcome back, welcome back. I'm Lisa Blackburn. This is my YouTube channel for everything I want to talk about math and science. And today this is chemistry class, and we are learning stoichiometry, which is a fancy word for a kind of chemistry math unit conversion. So I was just telling my students that this test is going to not be multiple choice. It's just math problems that you will do pencil and pen on a piece of paper. Now, some people said, so the last period they asked, is this the hardest test? Some people think so. Other people will say it's the easiest test because there's no vocabulary or anything like that. It's just math problems. And, really, you just put it in your calculator. Your calculator does the hard part. So just make sure you bring your calculator every day for this unit. And also be ready for pop quizzes. I pop quiz heavy on this. So it's not really quite a pop quiz because I'm warning you in advance that we're going to do a lot of quizzes to get you ready for the test so you're not overwhelmed. So if you are just very organized and you don't just try to do step one, step two, but you actually think through the problems, they're not that hard. So I have some students always go, that was the easiest test. That was great. And other ones go, that was terrible. So maybe most of y'all will say it was great and not terrible. All right, so here are our notes. We're going to start off with a few words before we get to the math problems. And the first one I already said is what this part of chemistry is called, is stoichiometry. So our notes say, how much does a reaction make? How much stuff do you need? These questions and more are answered by stoichiometry. Yay! All right, so this is how you spell it. It's a big word, Stoichio. See how they reverse? Metry. Stoichiometry. It's the first blank right there. Mass and quantity relationships among reactants and products in a chemical reaction. So what this is remember how we did the cookie lab that people brought in the cookies and we showed how reactions are recipes. Well, you've balanced these equations. You know about all the symbolism. How do we actually turn that into a recipe where I can go back in my stockroom, get the chemicals I need, and actually make it? Nowhere on that recipe does it say 4 cups of whatever chemical, does it? 3 teaspoons, a pinch of this, a sprinkle of that. So now you've got to learn how to take that balanced chemical equation and turn it into actually making chemicals. So that's what this is. And the part that tells us how much is the coefficients. The coefficients. So first we had to do the last chapter where we learned how to balance equations. Now we're going to take those balanced equations, and that's going to tell us the number of moles. So the third blank is moles. The coefficients is the number of moles, and the moles are going to tell us how much. Leave that off. All right, next idea. We're going to do, how I'm going to teach you this is through a lot of example problems. And the first one is making banana flavoring. Do y'all like Laffy Taffy? Yeah. Artificial banana? We're going to be making that flavoring. We're not going to be able to, in lab, we're going to do this reaction that I'm about to teach you. We're going to actually do it in lab. You're not going to be able to eat it, but you'll be able to smell it. And I just learned a new way to make it where you can smell it better. I was very excited about it. All right, so I used to teach this. The standards used to be different. And organic chemistry was part of it, and I did this lab then. And then they changed the standards, and so for several years I didn't do this. But then I rewrote the stoichiometry unit to use examples of this lab where you make these artificial flavors, and then I was like, oh, well, we can do those labs and do the reactions that they learn about. We're also going to be doing other reactions where we'll have more math in them. So, okay. All right. Next idea. Okay, so how you do this. Okay, I'm going to just write down the words first. There's the reaction for banana flavoring. We're going to go back and look at it in a second. But whenever you do a problem, right, you first write what you know. Yes. So, I missed the thing first there. So the very first thing is you write the balanced. I said it, but I didn't write on the board. You need the balanced chemical equation. Next, you write down what you know. Now, I'm going to be really picky about how you do this. There are some of you who will go, I don't need to do all that writing everything down. Well, you will not get credit. I only give half credit for the right answer and half credit for your work, which has a good side too, which means even if you do something dumb but your work is right, you can still, on all the problems, you can still make a 50. Yeah, it's failing, but it's an F+, and you can recover. So you get half for your work and half for the right answer. And I'm going to be really picky about how you write this. I have taught this for decades. We're not going to talk about how many. I've taught it to college kids and high school kids for decades. And when students do this exactly how I tell them to, they do great on this test. Doesn't matter which college I'm tutoring kids for or which college I'm teaching kids at or which high school it is. They always do good if they do this exactly how I tell them to. So because the key to doing good on this is being organized and then understanding where the numbers come from. If you have those two things, you're going to do great. I promise it. Okay, so you're going to write what you know under the chemicals, and you're also going to write, and just write this out to the side, there's not a blank for it. You're also going to write what you don't know. So just out to the side after write what you know under the chemicals, write and don't. Then you're going to use conversion factors to make the units consistent if you need to. If the units aren't consistent, you might have to straighten those out. Now, these problems, you've learned how to do all the different little parts of it, and now we're going to put it together. When we do these problems, they're going to take about half a piece of paper each. So they're big, fancy problems. A lot of places to make mistakes on them, but if you're organized and think it through, you won't. So so this is the first thing. We learned how to do this way back in Unit 1 for our Unit 1 test. We learned how to use dimensional analysis to do unit conversion. So let's remind ourselves of that. So here's our little reminder problem. 1 day equals how many seconds? What do I write down first?
What you know.
What I know. So I'm going to write down 1 day. Then what do I draw?
Train tracks.
Train tracks, that's right. See, I was being the train. Okay, 1 day. What do I write in the denominator across?
24 hours.
60 minutes.
What? Not 24 hours. What is it?
1 hour.
What? Somebody say it?
60 minutes.
Question mark.
No, not yet. What? No. Look, watch me.
1 day.
1 day.
What is it, Cameron?
Oh, I don't know.
Oh, I thought you were.
It's always in 1 day.
You write the unit day.
What?
So whatever unit you have here, you write down there. Now, if you know, you write the relationship. Do you know how, we'll go over here. Do you know how many seconds are in a day?
Yes.
What is it?
Oh, no.
No, we don't know that. But what do we know? How?
Hours.
We know hours. So we're going to write hours up here. And what's the relationship between days and hours?
24 hours in a day.
24 hours in 1 day. And so now I continue my railroad tracks. What goes catty corner and down? Hours. Whatever is here goes down there. Does everybody get that? Whatever's in the numerator here, that unit goes catty corner into the denominator here. If it's in the numerator here, and I think it's more fun to do if you add sound effects. Give it some sound effects. You just push it down there with the sound effect. Okay, so we're going to have hours here. What is something I know relationship with hours? How many?
60.
So 60 minutes is 1 hour. Now, once again, ka-ching, I push it down here with the sound effect. And now I can do my thing. How many seconds are in a minute? 60. Now, over here, what do I do to everything in the numerator? Everything in the denominator? Divide. So put it in your calculator, get out your calculators, and do 1 times 24 times 60 times 60, enter, and then you would do divide by 1, divide by 1, divide by 1, but really you can skip the ones because anything multiplied or divided by 1 is itself. Okay, so don't forget your 86,400 seconds. Don't forget your calculator this week. All right, so let's go on. Can I erase these words? Can I erase the problem?
Yes.
No.
No. Okay, I'm going to just erase the words. You know what's better technology than this is the old overhead projectors from the 90s.
Oh, yeah, you're right.
Wow. They're so.
If I don't get this TV fixed, that's what we're going to be using. So.
Did you use the teach with that?
What?
Did you use the teach with that?
Yes. Long time ago. All right. Y'all ready for it to go on? Okay, so another thing that you'll do, and right now I'm just telling you the steps. This is going to be a little bit confusing. But once we start doing problems, and once you start doing problems on your own, you can go back and look at the steps again to remind you how to do it. So I'm going to give you the steps. They won't make a whole lot of sense. We'll do problems. They'll start making sense. Then you do problems on your own, look back at the steps, and it should make more sense. Okay, so the next one is if you, okay, so everybody has to imagine this. Everybody imagine a graham cracker, not store brand. Those aren't any good. No, this one's real Nabisco graham cracker. Now, for my graham cracker, I'm going to put a little peanut butter on it. Smucker's all natural, no sugar or fats added. Okay, good peanut butter. And now imagine you're taking a big handful of M&Ms and you're sprinkling them all over and patting it down and taking a bite. Can everybody imagine that? I want you to imagine it hard because I want you to link in your brain graham and M&M. Graham crackers and M&Ms. Graham crackers and M&Ms. On these problems, whenever it asks for grams, we have to look up the molar mass. So our little symbol for molar mass is going to be M&Ms. So our next blank is look up the molar masses on the periodic table. And if it's not there already, draw a little M&M out to the side. And then you're going to add them up for each chemical. Actually, each chemical in the problem, but that'll make sense. And you're going to write it underneath. And I'm going to be really picky about where you write it, where you write this information. You're going to write it, and what we're going to do is we're going to end up making a table, a problem table based off of our balanced chemical reaction. If you're not converting with grams, write those ratios under the chemical 2. Chemical under. It's under. And this will make sense in a second. Write it under the chemical 2. Then you're going to write the mole ratio. And that comes from the coefficients. So write that too on this line. The mole ratio comes from the coefficients. You're going to draw a U, the letter U on your paper, and you're going to set up your conversion factors or train tracks. And then you do the math. There you go. So we'll do some examples once y'all have written that down. So this will be different than our regular test. You'll only probably be 10 or 11 problems.
Oh.
I usually, give you 80. This time it'll only be like 10.
Well, that means if you miss one, it's a lot more. So.
Exactly. You miss one, you've lost a letter grade.
Aren't the questions going to be like extra long? You just said it took up half a page.
Yep.
Wait, no way.
Can we have 80?
Thought you was going to have it easy.
Can you have what?
Yeah, 80 round.
80? No, not for this one. This one you get 10. Maybe 11.
That's going to take me like 2 days.
All right, can I erase it?
Yes.
Everybody good? Okay. All right, so let's talk about some problems then. So funny, we get such a tiny board. I'm such a nerd, I have a dry erase board at my house, so in case I want to do a problem, I can, like mounted to the wall, and it's about this big. So my little home board is about the same size as our class board in here. But it's nice, I like having a board. Okay, let's read through. I think that's just broken. Did you get it to work?
It was going nowhere.
Can
You
I borrow
can-
a handheld sharpener so I don't like disrupt the class?
Just don't do that. Use a marker or something. I don't want you to disrupt the class, and I don't want you to sharpen all those either. Don't bang them, it'll break the leads inside them that aren't really lead. All right, shh. Everybody focus. David, shh. Lana, shh. Focus. Focus. If you have a question, ask me. Then everybody can hear. All right, so we're going to read the problem. We're going to annotate the problem. Yes?
Will you send Desiree Farrell to the office for checkout?
I will.
Thank you.
So, Desiree, you can watch the video and get the rest of the notes. All right. Okay, settle down. Okay, so let's read this problem together. If you have 45 kilograms isoamyl alcohol, now, if they give you the problem in kilograms, you got to convert it to grams. Remember how we have our graham crackers? It's not kilogram crackers, it's graham crackers. If you're given something in kilograms, your first step is going to be to convert it to grams. And I just want you to be able to do that sort of in your head using King Henry's Daughter Bakes Delicious Chocolate Muffins. So, with that in mind, 45 kilograms is how many grams?
Let's see. 1, 2, 3, 4.
Yep.
And kills his daughter. What? 5.
What does kilo mean?
Big.
Doesn't it mean thousand? So it is, well, 45 kilograms is 45,000 grams.
How do you know that?
King Henry's Daughter Bakes Delicious Chocolate Muffins.
I thought you guys would like jump them. Like you have to jump to each
You
other.
do.
I'm in kilograms, I'm going to basic. 1, 2, 3. The decimal point goes 1, 2, 3. I'll augment zeros. 45,000. Remember that from Unit 1? Okay. So you have 45 kilograms of isoamyl alcohol, C5H12O. In the other class, somebody said, how do you know the formula for isoamyl alcohol? It's given in the problem. You got to read carefully. And enough acetic acid to react with it. How much banana flavoring can you make? All right, so what you do first is you write down your reaction. All right, so step 1, write down your reaction. Step 2, yes, sir? Yep, thank you. The next part was going to be hard if I left it like that. What do we do next?
Balance.
Balance it. See, I was off balance. So next we balance it.
Wait, what?
5 carbons plus 2 carbons is 7. 12 plus 4 is 16. 14 plus 2 is 16. 1 plus 2 is 3. 2 plus 1 is 3. This one's already balanced. Once you balance it, I want you to put a little check mark next to it. I'll know that you're not trying to fake me out and make me think it's right when it's not. That is just going to let me know as I grade the problem that you remember to balance it or to check to make sure it's balanced. Okay, good so far? Okay, the next step, we write what we know and what we don't know. And we know that we have 45,000 grams of isoamyl alcohol, and we're trying to find out how many grams of banana flavoring that we can make. So you write down what you know with the units, and what you don't know, write a question mark with the units underneath the chemicals. Feel good so far?
No, we explained that.
Okay. Step 1, write down the equation. Step 2, balance it. Step 3, write your given, what you know, what you're given, underneath what it is in the equation. Write a question mark underneath in the equation what they're asking for. The others, you just leave alone. Okay? Next step. Because these are grams, what goes with graham crackers? M&Ms. Because these are grams, we're going to draw a little M&M right there to remind us what to do next. Okay? And that is, we need the molar mass. Where do we get the molar mass?
Periodic table.
The periodic table. So, we go over to the periodic table. What I want you to do is, over here, you're going to list the chemicals. So we have carbon, hydrogen, and oxygen. We have 5 carbons, 12 hydrogens, and 1 oxygen. We're going to look on the periodic table and get their masses. Carbon is 12, hydrogen is 1, oxygen is 16. We're going to multiply them. 5 times 12 is how many?
60.
So you know the song. It started with a 0, 12, 24, 36, 48, 60. That's it, 60. I know y'all want me to keep singing by one. 12 times 1 is 12, not till we get over there and I get to sing again. 1 times 16 is 16. We add them all up. Remember this from our first test? And it's 88. Okay, I want you to put this in a little box over here. And over here you're going to write 88 grams per mole. Molar masses are in grams per mole. Be sure to write the units. Okay, now we... What?
Oh, 16.
Now we also need, because here are grams too, we need delicious M&Ms. We're going to have to figure out the molar mass of this one. So I'm going to kind of write it over here because the TV blocks for people over there. So I'm going to write C, H, and O, 7, 14, and 2, 12, 1, and 16. What's 7 times 12? It started with a 0, 12, 24, 36, 48, 60, 72, 84. Didn't y'all have little songs for all your multiplication tables when you were in elementary school? No? Well, it's because you didn't have me as a teacher. We would have sung them all. Okay. 14 times 1 is 14, and 2 times 16 is 32. Add them up, and you get 130. So now I'm going to put that in a little box out of the way, and I'm going to write my 130 right here underneath, 130 grams per mole. Any questions so far? I want the molar masses boxed because the neater and more organized we can be, the better your grade is going to be. Yes, sir?
That is a dash between the G and...
That is a slash. It is a fraction bar that I wrote as a slash. So that means the grams is in the numerator, the moles is in the denominator. It's grams per mole. I think it's fun because once you understand it and it's not really that hard, you will feel so smart, especially when you get to college and nobody else understands it but you, and you're the one that blows the curve. You're going to feel smart. Okay, so now we've got our molar mass line. We've got our knowns and unknowns line. We've got our molar mass line. Our third line comes from our balanced chemical equation. There is an understood one in front of our isoamyl alcohol, and there is an understood one in front of our banana flavoring. We write that right here as a ratio. Remember how we learned that moles can be written as ratios or as fractions? We're going to write it as a ratio. So I'm going to let y'all write that down and think about it a second, and then I'm going to explain it to you a little bit more. Okay, so this is sort of the heart of our problem. And if you get it wrong, after grading these for decades, this is where you're going to miss it. Not in this one, but later when you have an equation that you balance and there are not understood ones, students tend to flip this and get it wrong. But what is it? What is this mole ratio? Why is it important? Let me explain it and then you can ask your question. What this is this is our conversion factor that lets us go from one kind of chemical to the other. This is what I call the revolving door. Now, if you haven't seen the movie Elf, you might be at a disadvantage. And I normally show you a clip from Elf at this part, and I'll try to get the TV working so you can see it. But if not, you might have to watch Elf. Okay, so if you don't know, he's an elf. He's going, his name's Buddy, and he's coming from the North Pole to New York City to meet his actual biological father. He was adopted by Papa Elf. So he gets to New York City, and he's going around just being really impressed with everything. He's eating gum off the handrail. It's very nasty. But then he goes to a building, and he sees a revolving door. And he keeps going around and around, pushing the revolving door, just being so happy. And it's what allows him to go from inside the building to out on the street, where he throws up in the trash can. Okay, everybody remember that part of the movie? The revolving door of this problem is the mole ratio. So like when we start doing these on the board and you're stuck, I will act like Buddy the Elf here to remind you to write your mole ratio. Okay, everybody's got it down. All right, so the next thing we do here is we draw a U. Now, what you do is you put a dot at what you know, and then you draw a line around with an arrowhead to what you don't know. The U doesn't always go this way, like an Amazon sign. It could be that what you know is here and what you don't know is over there. That's why you draw the arrowhead. The U tells you the order to do the problem in. Yes, Jordan?
Why is the ratio 1 to 1?
Because there's an understood one here and an understood one there.
So when you get into
Yes, then there'll be different numbers.
so like say you had a 2
Then it would be 2 to
to
1.
1.
Mhm.
Wait, so where? Why specifically those places?
These ones came from the coefficient of what you know and the coefficient of what you don't know. They just happen to both be ones this time.
Oh, so like if you were balancing an equation and you need to like multiply that the one you don't know by like 2, would it be like 1 to 2?
It would.
Oh, okay.
Okay, how are we feeling? Good so far? Okay, the next thing we do is we're ready to write our problem, and we start by writing what we know, right? And that's this. So we're going to write 45,000 grams of isoamyl alcohol. I'm just going to abbreviate it IA. If you were doing this for real in a book or something, you would write the whole chemical out. But we'll just do IA. Okay, so now we draw our train tracks, right? And now what goes in the denominator?
Grams.
IA. Grams of IA. Now, what number goes with this? Where we get the number is going around. Here was our first thing. We come to the next thing and look. Grams. 88. What's on the other side of the fraction bar right here? Moles. So on the other side of this fraction bar, I write moles of IA. What number is understood to be with that mole? 1. And this is an understood 1 mole. 88 grams per understood to be 1 mole. Does that make sense to you? There's an understood 1 with that mole that I wrote right there.
Is that mole IA or MO/IA?
That is mole IA.
Oh.
1 mole IA. Mole is MOL. You're allowed to leave the E off for its abbreviation. Okay, so now we continue our train tracks. What goes down here? Mole IA. Now what number goes with this? Well, we come right here to C. What number do we have here? A 1. Now on the other side of the fraction bar, what do I have? A 1. But this is moles of BF, banana flavoring. Because now we're on the banana flavoring side. We were Buddy the Elf. We went through the revolving door. We're not in the store anymore. We're out on the street. We're not with the isoamyl alcohol anymore. We're with the banana flavoring. Good with that idea? Okay, so now as we go on around, what goes down here?
Banana.
Moles of banana flavoring. Okay, and where is that mole? It's right here.
Yeah, 130.
So what is the number that goes with that mole? 1. And what's on the other side of the fraction bar? 130 grams of banana flavoring. We go through and we mark out if something's in the numerator and denominator, they cancel out just like math class. So grams of isoamyl alcohol cross out, moles of isoamyl alcohol cross out, moles of banana flavoring cross out, and I'm left with what I was looking for, grams of banana flavoring.
So the answer is 180 grams.
No. The answer is everything on top gets divided, everything on bottom gets multiplied, everything on bottom gets divided. Put it in your calculator and let's see what the answer is. 45,000 times 1 times 1 times 130, enter, divided by 88, enter. Really, you can skip the ones because anything multiplied or divided by 1 is itself.
66,477.
66,477 grams. We don't want our answer to be more precise than our number, right? So, and then if they wanted kilograms, it would be, we'd just round it to 66.5 kilograms. Approximately equal to.
You have to do this for every single time.
This is a typical problem. Okay, we'll start here.
The solution for the top one, you gotta divide it by the solution for the bottom one.
The easiest way to get it for your calculator to give you the right answer is to multiply all the top first. Any numbers that aren't 1. So do 45,000 times 130. Then hit enter. If these were numbers, whatever they are, every one of them hit times, enter. Then do divided by, enter, divide by, enter, divide by, enter. You can multiply all the top ones together, then hit enter. But after every divided by, hit enter. Otherwise, your calculator will sometimes only do part of the problem. It won't understand it to do the whole thing.
Yeah, because I multiplied them all, divided all of them, and divided it all together.
And you got the right answer? Partly probably because there's ones down here, though. Because those won't always be ones. Yes, CJ?
Wait, so you have to divide it like every single time for each, like...
Depending on your calculator. That's one reason why you've got to make sure that you are practicing with your calculator. Don't wait till test day and borrow my calculator. Use your calculator. Learn how to put it in your calculator and to get the right answer. Because you've got the good expensive calculators now that you can take to college and know how to do it for your college test. Yes?
Well, I mean, like, so you can't, like, multiply the bottom numbers. You have to divide it for each one.
You could get the right answer also if you multiplied all the top and wrote that down. Multiplied all the bottom and wrote that down, and then took the top divided by the bottom. But it's easier, it's less writing things down. You could just do it on your calculator without having to write anything down. If you multiply all the top, enter, divide by enter, divide by enter, divide by enter.
So do we not have to put the decimals after 66477?
Well, no, because that is our whole thing about. I didn't actually do significant figures, but just always beware of making your answer look more precise than the information given in your problem. I'm not going to stress significant figures in this. But at the same time, don't write down a bunch of decimal points because we were not given decimal points to start with. Where did we gain precision? We didn't gain precision from anywhere. So our answer doesn't need to be more precise than our problem was, than our data was. Any other questions? David, what you got? Turn around and face me. Don't talk unless you have a question, and then ask me, not Lana.
I didn't talk.
Well, I was hearing a little buzzing back there while Jordan was asking his question. But it was Lana. Lana, calm down. Okay. All right. Yes?
So we don't put in decimals? Like
No.
round them up?
No, yeah. We don't want our answer to look more precise than our knowns are. That's not being honest with our data. Remember, we got to be honest scientists. All right, so how do you feel about that one? If you can do this problem, you can pass the test. You won't get an A, but you can pass. if you can do this problem multiple times with different variations. But there's going to be more. Can I erase it now?
Yeah.
Yes? All right. Let's do another one. That was fun. Let's do another one. I think it's fun. I love math. I think math is great.
Well, that's the best part of this class. What?
Sure, but I'd rather learn definitions.
I like math better than definitions. I like to read books. Well, I used to. I don't have much patience for it anymore. Okay, let's do number 2. Methyl salicylate C8H8O3 is also known as oil of wintergreen. We're going to make that in lab too. It's made in a reaction between methanol and salicylic acid. How many grams of salicylic acid are needed to produce 325 grams of methyl salicylate with plenty of methanol? Okay, so step 1, we write our,
Well, we know.
not yet,
Balance.
our equation, and then we'll balance it.
Because our equation is already there. That's
Yeah, it's already there, but I have to write it. CH4O plus C7H6O3 yields C8H8O3 plus H2O. Okay, now what do we do next? Check and see if it's balanced, is it? 1 plus 7 is 8, 8. 4 plus 6 is 10, 8 plus 2 is 10. 1 plus 3 is 4, 3 plus 1 is 4. Check, it's balanced. Okay, so now what do we do? Write what we know.
325 grams.
Of what? Which one do I write it under?
Methyl salicylate, which is
That one.
CH8O3.
So write 3, and what do I don't know?
CH4O.
No.
Oh, C7H6O3.
Yes. That's the one I don't know. So this time my U is going to go the other way. So that's just to show you that it can go both ways. Okay, we have delicious graham crackers, so what do I need? M&Ms. M&Ms. I have a niece who, when she was little, should say it wrong. She couldn't say M&Ms. She'd say N-M-Ms. N-M-Ms. Okay, so I get the mass off the periodic table. So I'm going to do this one. I have 7 carbons, 6 hydrogens, and 3 oxygens. So that's 12, that's 1, that's 16. Then we're going to add them all up. Y'all can do it later if you want to. It should be 138. So 12 times 7, started with a 0. 12, 24, 36, 48, 60, 72, 84. 3 times 16, isn't that 48?
Yes.
All right, there we go. Did that one. And now we got to do this one. C is 8, H is 8, O is 3, 12, 1, 16. Okay, so we did. Started with a 0, 12, 24, 36, 48, 60, 72, 84, 96, 108. I want to keep singing. 8, 16 times 3 is 48. Add them all up, and it's 152 grams. Put these in a little box so they're out of the way. They won't confuse you with the rest of the problem. But here we put 138 grams per mole and 152 grams per mole. Okay, feeling good about that?
Yes.
Wait.
I have a question. Oh.
You want me to sing again?
Yes. I want to know that song for the times 12 multiplication.
No, we're going to stay on task here. Sam, are you awake? Okay. We got to get through at least as much as first period did. So, all right, so what goes next?
Oh yeah, ratio.
The mole ratio.
1 and 1.
1 and 1. Now what do we go?
The U.
The U. So I'm going to do that in a different color. We start with what we know and draw it around to what we don't know. So that's going to tell us the order to do the problem. The U is important. The U tells us what to do. If we get to here, we've done it. We just have to write it down in the order of the U and let our calculator do the work. Okay, so we're going to start with what we know, which is this. 325 grams, and we're going to call it W for wintergreen flavor. What goes in the denominator? Ka-ching. Grams of wintergreen. So as we follow along, there is our first thing. Our grams of wintergreen is right here, 152. On the other side of the fraction bar is 1 mole of wintergreen. That mole right there. Yes, sir?
Wait, where did the 325 come from?
Well, it was given to us. It was our know. It's what we know. Yes, sir?
Why did we start on the right side?
Because it can go either way. It's not which side it is. You go from what you know to what you don't know. It can go either way. Yes.
Why'd you put 1 mole first instead of 152?
Because I knew this was gram per mole, and then I went back to fill in the numbers, and since I had just written mole, I wrote 1 and 152 because it's from right here. Okay, good so far? So now we're going to follow this around. What goes in the denominator? Ka-ching! Moles of wintergreen. What number goes with moles of wintergreen? 1. It's that one right there. Not the other one. It's this one. What goes on the other side of the revolving door? Moles of what? For salicylic acid.
Yes.
So salicylic acid, and the number that goes with it is 1.
What's the Frigidaire? Frigidaire.
Okay? Good? Okay, so now we continue our train tracks. What goes down here? Ka-ching! Moles of salicylic acid. What number goes with moles of salicylic acid? 1. 1. It's this mole right here, and it has an understood 1 with it.
Wait, that's what the other one's for, right?
What?
That one right there you just put down.
Yeah, the 1 mole up above.
That's this one is right there. This one is right there. This is moles of salicylic acid. That's moles of salicylic acid.
So every mole is 138.
That's going to be on the other side, which is grams of salicylic acid. And what number goes here? 138. Because this is a fraction bar. That fraction bar is this fraction bar right here. They're the same. Let me get rid of that. It's a little confusing looking. Now we just let our calculator do the math for us. Any number on top gets multiplied. Any number on bottom gets divided. Put it in your calculator and see if you get the right answer. 295 grams of salicylic acid. Salicylic acid is aspirin.
Yeah.
So do 325 times 138, enter, divided by 152, enter.
Wait, so why is the 1 mole under 138 there? I thought it was just.
It comes from right here. 138, it's not grams are not on the periodic table, it's grams per mole. So that is part of this unit, grams per mole. And that's that mole right there.
Okay, so you would do that for like every problem.
Yeah, that's like this you would. But there's going to be variations. All right, good job. Any more questions before I erase this one? Any more questions about this one? Doesn't look too hard, does it?
I probably get overly confident.
Yeah, exactly.
Well, what's going to make you confident is practicing problems and getting the right answer over and over again. I'm going to give you worksheets with answers. You're going to do it and see if you get the answer or not. Just like how I gave you the answers last time, I'll let you take pictures of the keys. I'm going to give you the answers this time. Because, right, I will not give you credit. If you just write down an answer with no work, without showing me this work, I assume you cheated and no credit. You have to have work to get credit. So the answer is not going to give you credit. What's going to give you credit is the answer with the work. And some of y'all love doing math in your head and are really good and hate writing things down. I'm sorry, you're going to have to write it down this time. That's the bad thing about the broken TV. All right, can I erase it? Any objections? All right, let's do the next one.
Your opinion is a dog.
I also have more videos on my YouTube channel with more problems under the, yours is Elements of Chemistry, but if you look at the other chemistry playlist, there is a whole nother like hour lecture on stoichiometry with different example problems. So if you want more problems worked out, this method, that's a place you can look for them. I'll put the link on your Canvas too for an extra resource. All right, let's look at our next one. Next page.
Why do they gotta switch it, bro?
How many moles of water are produced by 14,000 moles of hydrazine rocket fuel? We will not be making this.
Why not?
Grams, mole to mole, mole to gram. All right, so first we need our equation.
We have our equation. We gotta balance the equation.
Balance it. It's not balanced. Y'all balance it. Practice balancing your equation.
4 + 2.
Okay, so 2 nitrogens, 4 hydrogens, 2 hydrogens. So what do I need in front? Oh, wait a second.
I said 2, 3, 4.
Yeah, that's wrong. Because I'm going to have to go back and change it. 2 plus 2 is 4. Here I have
You need a 2 then.
2.
Yeah.
Not yet though.
Now we missed it.
Yeah, I said 2.
It should be 2, 3. It's going to end up being 6 and 4.
Oh, okay.
That's what I had before.
Because it's the oxygen. See how there's 4 oxygens here? We had to have 4 oxygens here, which is that made 4 times 2 is 8 hydrogens. So we had to go back here and put 2 to make that 8. 2 times 2 is 4, plus 2 is 6. 3 times 2 is 6. So now we have our balanced equation. Put a little check. Okay, next, we write what we know. And what do we know? What's our number they give us our problem?
14,000.
Okay, and which one do I write it under?
Into
Into
H2O.
This one right here. And what's the units with 14,000? Moles. Okay, and what do I not know?
Grams.
No, first they ask you for
How many moles of water?
moles. So first they want to know
How many moles of water?
how many moles of water. So we're going to do it twice. The first time we're going to do it we're going to do it mole to mole. Okay, do we have delicious graham crackers? No. So do we need M&Ms? No. So we can go straight to,
Straight track.
no?
Ratio.
Mole ratio. And what is it? What's the mole ratio?
2 to 4.
2 to 4.
It's Black Brian.
Uh-huh.
You heard that.
What? Did I miss cussing or someone passing gas?
I'm sure you'll play it back on the video.
Oh, you think it's on the video? That'll be funny. Okay. Now, what are we going to do?
Let's go.
What do we draw next?
Are you?
Are you? Where do we start with what we
On the left.
know? So this time we're going this way. Around to what we don't know. Now we write down what we know. See, this is actually easier, isn't it?
Yeah.
And we'll call it H for hydrazine. And now we draw our train tracks. What goes in the denominator? Ka-ching!
1 mole.
Moles of that hydrogen. But how many moles? 2. And what goes on the other side of the fraction bar? 4 moles of water. And we'll draw Mickey Mouse because that's cute.
Water.
Water. Okay, I'm looking for moles of water, and I'm going to end with moles of water, so I don't need to write anything else. Do you see that? This one is actually way easier. But do you know more people miss it? They get tripped up by the easy. They get in a pattern of liking the hard. That's why you don't just do the pattern. You have to think about what you're doing.
Oh, that's it. With a W.
That's it.
That's it. Let's put it in our calculator.
Oh,
Multiply it on top, divide on bottom. It equals 28,000 moles of water. Put a box around it. You have to box your answers because remember I have cheater kids who try to do it every possible way and say, it's there. The right answer is there. Yeah, and also 5 wrong answers are there. You have to decide on your final answer. Okay, it also asks us to do grams. So I'm going to write it again. I'm going to draw a little line here and write it again. So I'm going to write my equation again. Oh.
Now you gotta change the grams.
yes.
Right. Remember and I wanted to show you this one because especially in college, they love multi-part problems like this. They love them to have more than one part. So I wanted to show you how to deal with it if they ask for more than one part. What we know is still what we know. But what we don't know is grams. Now we have grams, delicious graham crackers. So what do we need? M&Ms. So over here, we're going to draw a little M for M&Ms. And we need to figure out the molar mass. Where do we look? The periodic table. So hydrogen, I have 2 of them. Oxygens, I have 1. Hydrogens weigh 1. Oxygens weigh 16. 2 times 1 is 2. 1 times 16 is 16. Add it together, it's 18.
Yeah.
And you're going to end up memorizing that water is 18 grams per mole. It's in so many problems. You're just going to end up knowing that one.
I can't. Sorry.
Oh, so you only gotta do it right because it's already. Oh, hey.
Okay, so now what do we do?
I have to,
Train track. Ratio.
Mole ratio. Don't forget Betty. And it's 2 to 4 again. And now what do we draw?
train track.
No.
We gotta draw the U.
You're getting ahead of yourself.
L.
Not yet. Got to draw a U from what we know to what we don't know.
Why?
And now we can write,
Train track.
1,000 moles. Why is it not grams?
because it's already moles. The reason why you do we don't need grams here. We don't need grams unless they give us grams or ask for grams.
I'm gonna start crying.
Unless they give us grams or ask for grams, we do not need molar mass. We only eat M&Ms with graham crackers. Only with graham crackers. All right, so now we're going to start with what we know. 14,000 moles of hydrazine.
You know what? I hope you don't.
Okay. Now, what goes next?
Am I here now?
2 moles of hydrazine. What goes on the other side of the fraction bar?
4 grams.
4 moles of water. That's our water. What goes on down here in the denominator?
1
Ka-ching.
mole of water.
We are going to right here, 1 mole of water.
What?
There's our water guy. And what's on the other side of the fraction bar?
18 grams.
18 grams of water. These cancel out. Those cancel out. We're left with grams of water. Do it on your calculator and tell me what it is.
What does that say on the bottom and then the top?
18 grams of water, 1 mole of water. But I drew a cute little Mickey Mouse.
4,000.
Why'd you put 1 more on it?
Because it's this mole right here has an understood 1.
504,000.
There's an understood 1. If it helps you to write the 1, write it.
Okay.
You know? All right, so the right answer is 504000 grams of water. So 504,000 grams of water. Okay, y'all seem to be doing good so far. Nobody's cried, nobody got a rash.
I'm gonna cry at one.
Got a rat.
I used to tutor kids who were, the parents would pay me a bunch of money to work one-on-one with kids. And I had kids who would bust into tears the minute we would start even mentioning fractions or math or stuff like that. And then I would also have kids who they would just start getting red splotches. It'd start on their neck or right here, and they would just start getting red splotches that start breaking out in a rash. So whenever I teach math and nobody cries and nobody has a red rash, I'm feeling pretty good. I had one girl, I started working with her when she was in 8th or 9th grade, and she would just bust out crying and start getting splotches. By her senior year, I was invited to her graduation. She said she gave a speech, and she said as part of her graduation speech that math was okay. She said, thanks to Miss Blackburn, I now can say math is okay. She never said she loved it or that's great, but by the end, her senior year, we got her where she would not cry and get a rash. So, yay. All right, you ready for the next one? May I erase this one?
Yes.
All right, let's do another one.
Whoa.
Please.
Yeah, can we skip at 3 minutes, please? Just 3.
All right, let's do another one.
What is this?
All right, so here's our next one. Find the mass of sugar required to produce 3 liters of CO2 gas at STP, liters to gram. Hint, was the volume of 1. So first let's write our equation. C6H12O6 yields, this is a decomposition, and I balanced it for you. I was being nice. And I'll do that on the test some too. I won't make you balance every one of them. Okay, so what do we know? What is our given in this one? 3 liters of carbon dioxide. So underneath carbon dioxide, I write 3 liters. I can write 3 liters of CO2, carbon dioxide.
Wrong way.
That is my known, okay? And what they want to know is the mass, so that's grams of sugar. Now, notice we do not have delicious graham crackers here, nor do we have moles, we have liters. Now, it's not his primary number we think of, but he actually figured this one out too. He's fabulous. He's Italian. Who is he? Avogadro. And his number is for particles or molecules or atoms. That's not what we need. The other thing that he found out was that a gas at STP, it's not Stone Temple Pilots or Standard Oil Treatment, whatever that thing is. He found out it doesn't matter what gas it is, if it's at standard temperature and pressure, the volume it takes up is 22.4 liters. So that is the number that if you are given liters, you write 22.4 on the next line.
Why?
Because of Avogadro figured out that any gas at STP, at the same temperature and pressure, takes up 22.4 liters of volume.
I think I'm gonna do.
Okay, and it's liters per mole. So that's where we're getting to our revolving door. Liters per mole. Okay, but over here I have grams, so what do I need? M&Ms. Graham crackers have to have M&Ms, so I'm going to list them. C-H-O, 6, 12, 6, 12, 1, 16, and if you add it all up, you get 180 for this one. So we're going to put that in a little box. You can go ahead and do it all out and double check that you know how, but it's 180 grams per mole of sugar. Yes.
So Avogadro's number is 22.4 moles.
6.02. Oh, his number is 6.02 times 10 to the 23rd. But whenever you have liters, the number that goes underneath is 22.4, no matter what the gas is. It'll be a gas, and you'll write that down in liters. So that one's easy because you don't have to add anything up. Yes, CJ?
Wait, so when you say that, are you saying like 22.4 liters is a mole?
Yes. 22.4 liters of any gas is a mole of that gas.
Okay, I get
Which is 6.022 times 10 to the 23rd particles.
Is that only in STP?
Yes. Okay, that was really important. If you weren't listening to that question and the answer, let me recap. 1 mole of any gas at STP takes up 22.4 liters. If you change the temperature or the pressure, it'll change. And we're going to do a whole unit on gas laws, and I have songs for that. Don't worry. And and you'll learn more about it. But any gas, doesn't matter what kind it is, at STP, 1 mole of it takes up 22.4 liters. Okay, so now we have molar mass. So for both of these, we've gotten to moles. So what do we need next?
Ratio.
The ratio, which is what?
1 to 2.
1 to 2. Now what do we draw? The U. And we start with what we know and go to what we don't. So we're going to start here and go around over to here. And that tells us the order to do our problem in. And we start with what we know, which is 3 liters of CO2. So what goes down here? 22.4 liters of CO2. It's got to be liters of CO2. What goes on the other side of the fraction bar?
Moles.
Moles, how many? 1. 1 mole of CO2. What goes in the denominator? Ka-ching. Moles of CO2. How many? 2. See what comes next on my arrow is 2.
Yeah.
What goes on the other side of the fraction bar?
1 mole of sugar.
1 mole of sugar. We'll call it big S for sugar.
BS.
Okay, now we keep going around. What goes in the denominator? Moles of sugar. And what number goes with it?
1.
Understood 1. Everybody understand that?
Yeah.
Understood 1. What goes on the other side of the fraction bar? 180 grams of sugar. Liters of CO2 mark out. Moles of CO2 mark out. Moles of sugar mark out. And you're left with grams of sugar, which is what you were supposed to get. Do it on your calculator and see if you get the right answer. So see, it's following a pattern, it's being organized, but it's also thinking through what you're doing. Otherwise, you'll get confused. You'll be like liters, and before you know it, if you're just doing the pattern, you'll start looking up the molar mass when you don't need it. You've got to think about it. Another big hint here.
What the freak?
David,
You get 12.
pay attention to me. The other thing is, listen, you need to not just write 1 mole or 22.4 liters. You need to write what it's of. That will help you see that you've marked everything out and that you did it right. You only mark out if you have the same thing in the numerator and denominator. Don't get lazy and just write 1 mole over 2 mole or 1 over 2, because I promise you, you'll end up flipping this and getting the wrong answer. It will help you keep it straight, keep it organized, and keep it right if you do that. All right, any questions so far?
I did not get 12.
3 times 180, enter. Divided by 22.4, enter. Divided by 2, enter.
Yeah, because I'm pretty sure what you're doing is you're just doing it, you're adding them all up and then dividing by the sum.
Yes, sir?
You said you can also multiply the bottom row, right?
But I don't want you to. I want you to practice doing it this way on your calculator, because if you multiply the bottom row and then divide, you're going to have to write it down somewhere or re-enter it into your calculator. That's opening opportunity for mistakes. This you can do all on your calculator without writing anything down, and so you're not opening up opportunity for mistakes. Oh, but if you want to, you can do it the way you want to, multiply all the top, hit divide, do beginning parentheses, 22.4 times 2, end parentheses, enter. That works too if you want to use your parentheses.
Oh, there's another one.
Yes, there is. However, with all the problems with the broken TV, this is as far as we got in first period. So for you guys, we're going to do something different. Hold on. Math is great. Like, share, subscribe.